All right, guys, so what we're going to be talking about here is we're going to be talking about lines. Now, this should be a topic that you're already fairly familiar with just because you've learned about lines all through probably starting in like 7th or 8th grade, and you've talked a lot about lines. The lines we're going to be talking about here are no different than the ones that we've talked about in the past, but we just need to make sure that we're all on the same page as far as talking about lines and what goes into the lines discussions that we have to have, because lines do play an important part in some of the things that we talk about in calculus, okay? So just a couple of things when it comes to talking about a line. When we talk about a line in math, we're just talking about a bunch of points that join together to make a pattern that look like a straight line. In math, when we talk about a line, there are no curves to the line. So this right here, you can see on the screen, this is a picture of a line. Now, in general, when we talk about lines, there's a couple things that have to be true about talking about lines in general. One of the things is any line that we have has to cross through at least 2 points. In other words, you have to have 2 points and then connect them together, kind of like a connect the dots type thing. But that is one thing that is true about all lines, is they have to have at least 2 points. In general, they have way more than just 2 points, but you have to have at least 2 points in order to have a line. Another word that we use a lot, especially in this class, is what is known as slope. Now, slope is generally how steep a line is, and it's given a number. The bigger the number is, the steeper the line is, and we talk about slope as something as we move from left to right. In general, when we talk about any behavior in mathematics, we always say that we're moving from left to right, and a line is no exception. So when we're talking about a slope, we're saying how steep is that line as it moves from left to right. And you found that the definition, you've heard a lot of definitions before: rise over run, y2 minus y1 over x2 minus x1, change in y divided by change in x. All of those are correct definitions of the slope. Basically, you're just finding out how fast something has changed over a given interval of x values, if you will. Another number that's not quite as important, but we do use it from time to time, is the y-intercept. Now, when we look at this graph, for example, the y-intercept is just where the graph crosses the y-axis. Another way to look at that is what the y value is when our x value is 0. Okay, every point is made up of an x value and a y value. This is no different, and when our x value is 0, the y value that goes with it is what is known as the y-intercept. Okay, we talked about this just a second ago, and this is the formula we're going to use. When we're trying to find slope, we are going to use this formula right here: y2 minus y1 over x2 minus x1. And the x's and y's here are just 2 different points that are on the line. And as long as the points are on the line, a couple of things don't matter. Number one, which point you choose to be the first point and the second point, and number two, what the 2 points on the line are. You'll always get the same slope as long as those points are on the line. So, and the other thing is we always have to stay consistent, Like if this is the first point we choose, then the x value from that point is x1 and the y value from that point is y1. You can't like mix and match them. Again, it doesn't matter which point is which. We just have 2 different points that are on the line. We have to stay consistent with that. And that should sound vaguely familiar to you. Okay? Rise over run, another way that we describe that from time to time. Another couple things that we'll need to know in this class as we look at lines is what the slope is of both a horizontal line and a vertical line. As a brief reminder, a vertical line is a line that goes straight up and down. Okay, so it's up and down. What's happening here is there is no change in y values, so we're dividing by 0. Okay, now when we divide by 0, you should have learned this back in the day. You can't divide by 0. So when we try to divide by 0, we get what is known as an undefined slope. And that's what's happening with a vertical line. We just have a slope that is not defined because we can't figure it out. If you're dividing by 0, you can't do that, but since there's no change in y, y2 minus y1 is going to give you 0. So that's why the slope of a vertical line is undefined. The slope of a horizontal line, and a horizontal line is just a flat line like that, the slope of the horizontal line, is always, always, always 0. So our slope here, and the letter that we use for slope often is m, our slope is 0 of a horizontal line every single time. Now, in this class, you'll be asked to find, and they'll disguise it. It won't just be like, hey, find the slope, but you'll be asked to find a variety of different slopes in a variety of different ways. One way that you'll be asked to do that is if you're given a table of values like this. These are just select x values and select y values. So like this is 1 point, like this is like first point that I can see on a graph, a second point, on and on and on. We can see all of these different points that exist on the graph. If I wanted to find the slope between any 2 points that exist on this line, we would just follow our formula that we have. Now, I will say that anytime we are given an interval, even though it might look like it's a point, like that kind of looks like a point right there, -3, 4. Anytime we are given an interval and it says that it's an interval, those are always both x values. So in this case, I'm trying to find the slope of a line that passes through all of these different points, but I want to find the slope on the given interval from -3 to 4. Now, technically, I could choose any point that I want to between -3 and 4, but by and large, what we do to find the slope is just find the slope between those 2 points. So here is my first point. Here is my second point that I'm trying to find the slope for. So I'm going to use my formula, y2 minus y1 over x2 minus x1. If we're saying this first one is our first point, and then this down here this time is our second point, just because we're using the points on the end of the interval, what we would do is we would say y2 is 4, because that's the y value right here, minus the y1, which is the y value on the first point in question. So that's 4 minus 6 over, then we find our x value, so x2 minus x1, that would be 4 minus -3. So that gives me -2 divided by 7. That would be the slope of the line that passes through those 2 points, okay? And again, we'll get a little bit more into how to do that. It is a little bit different depending on how we're looking at the problems, but we're still just trying to find the slope between 2 points, and that's what I did right there. Okay, so hopefully that kind of makes sense. Here's another type of question you might be asked. What is the slope of the line that passes through x equals 1? You'll notice we have like a piecewise function here that behaves differently depending on where we're looking at the graph. X equals 1 is right there, and if I wanted to find the slope of the line that passes through that point, what we would do is we would say, okay, I'm going to choose 2 points that I can see on the graph. Here's 1 point. 1, 1 is a point that's on the graph. I can also see that the point 2, -1 is on the graph. Notice now I have 2 points that exist on the graph, and if I want to, I can find the slope that exists between those 2 points. So I just go y2 minus y1 over x2 minus x1. In this case, that's -2 divided by 1, which gives us -2, and that's how we would find the slope of this line. Again, this should be review for you. You've learned how to find slope before, so we might be asked slightly differently how to do it, but this is still the same thing that you've done in the past looking at slope. One of the reasons why this question was more difficult is you weren't given a specific set of points. Like if I'd wanted to, I could have used this point as well. This point, 0, 3, and if I'd found the slope between that point, like 0, 3 and 1, 1, I still would have gotten -2, or between 0, 3 and 2, -1. So you don't have to just choose one point and go with it. You can go with any points you want that exist on the line, and it will give you the correct slope, okay? Another thing that's really important in this class is you've learned in the past that the equation of a line is y equals mx plus b. Okay, where m is the slope, b is the y-intercept. That should sound vaguely familiar. That has been something that you've used in the past, and there's nothing wrong with that formula. That formula especially is very useful in statistics, is one place where it's much more useful than what we need an equation for in this class. In this class, we will not use that equation for the equation of any line. Instead, we're going to use this equation called and this is slope-intercept. That's what that was. We're going to use point-slope form is what it's called instead. Okay, slope-intercept was y equals mx plus b. We're not going to use that. Instead, we're going to use y minus y1 equals m times x minus x1. Now, anytime we write the equation of a line, we never put anything in initially for y or for x. Those need to be included if we're writing the equation of any line. y1 and x1 are simply a point that exists on the line that you're talking about. So if I'm looking for a point on a graph, and I can see one particular point that I know exists on a graph of a line, then I could put that in for y1 and x1, and that would be an equation that I could use for that line. m is the slope. Again, we've talked about this before, but m is the slope of the line that we're looking at. So if I'm trying to write the equation of a line, I'm going to have y minus some number, so I always fill that one in, is equal to another number, that's our slope, times x minus the x value that comes from a point that exists on the line itself. Okay? That is how we fill out every equation of a line. So in this case, if I knew that the slope was 2/3 of a line and the point 3, 4 was on the line in question, what would the equation of that line be? Well, I would go y minus y1 equals m times x minus x1. And then I would just plug in, like this right here is my x1 and my y1. So I would go y minus 4 is equal to, notice m is our slope, and it tells us in this problem that the slope is 2/3 times x minus 3. And we would just leave our answer like that. One thing that's really nice on the AP exam is once you get the equation of a line, which you will have to do from time to time, you just leave your answer just like this. We don't have to simplify. We don't have to get our y by itself. We're all done once we hit this point right here. Now, if I'm looking at two lines and I say that they are parallel to each other, okay, we know that that basically means that those two lines are never going to touch each other. Mathematically, what that means is the slope of both of those lines is exactly the same. Even though they have a different y-intercept, even though they pass through completely different points, the slope for both of them is the same. And so that is what makes two lines be parallel. So if I hadn't, notice I've got this, write the equation of a line that is parallel to y equals 3x plus 2 and passes through the point 1, 4. Well, if I'm going to write the equation of a line, it's just y minus y1 is equal to m times x minus x1. Notice I need three things. I need x1, y1, and m. Well, here's my x1, that's easy. Here's my y1, so I can plug those in immediately. So I get y minus 4 is equal to x minus 1, but I don't know the slope of the line that I want to write the equation for. Well, notice that this is y equals 3x plus 2. That's like y equals mx plus b. If that's the case, then the m right there is just the number that is in front of the x, so that number is 3. Now, you might be saying to yourself, Self, why do I care what the slope of that line is? Well, if two lines are parallel to each other, then if the slope of this line is 3, then the slope of the line that we're writing the equation for must be 3 as well. Otherwise, those two lines aren't parallel, because that's what it means for two lines to be parallel. They have the same slope. So now I've written the equation of that line. Y minus 4 equals 3 times x minus 1. We don't need to simplify it. We're done writing the equation of that line. Okay? Hopefully that kind of makes sense, and it's a brief reminder to a bunch of things that you've learned about as far as lines go. Those are the important things that you need to remember when it comes to lines as we talk about it in this class. If you have any questions about this or anything else, please let me know.